In the rapidly evolving world of AI and machine learning, staying ahead requires more than just foundational knowledge. There is a way to elevate your skills and tackle real-world challenges with confidence, and that's mastering advanced AI ML techniques. Today, we'll explore the cutting-edge methodologies that empower AI ML engineers to innovate and make an impact across industries. By the end of this video, you'll be able to explain the purpose and scope of this course, understand how advanced AI ML techniques can elevate your expertise. You'll be able to identify key methodologies covered in the course, exploring topics like federated learning, ensemble methods, differential privacy, and generative artificial intelligence. You'll also be able to recognize real-world applications, discovering how these techniques are applied across industries to solve complex challenges and drive innovation. Truthfully, it's about combining theory with pragmatism to solve complex problems across industries. Here are a few key topics which we'll delve into later on. First is federated learning. That's privacy-preserving AI that enables collaboration across distributed data sets. Then we'll talk ensemble methods, harnessing the power of multiple models to boost both accuracy and reliability. We'll also discuss data sharding, efficiently managing massive data sets through a distributed system. Then we'll talk about differential privacy, which is balancing data utility and privacy with robust techniques. Finally, we'll touch upon generative artificial intelligence, creating transformative solutions in content generation and well beyond. This course is your bridge from learning to doing. Here's just a sampling of the few things with which you will engage. First up is hands-on projects. You'll solve real-world problems with confidence. You'll leverage Microsoft Azure, one of the most powerful AI ML platforms, to maximize your impact. And you'll receive expert-led support, guidance at every step from first deployment to optimizing advanced systems. By the end, you won't just know the techniques, you'll own them. In this video, you learned about the purpose and scope of this course. We talked about the key topics we'll cover and the techniques we'll use. What are you waiting for? Come with us on this journey of advanced techniques, and let's get started.
Think of Git as your project's safety net. It keeps track of every change, every addition, and even every mistake, allowing you to go back in time or collaborate seamlessly with others. In this video, we're going to show you how to set up a Git repository for your machine learning project so you can code with confidence and keep everything under control. By the end of this video, you'll be able to create and set up a Git repository for your project, and organize your files and structure your repository. Let's begin by initializing a Git repository for the project. Let's go to Notebooks, and let's create a new folder where the Git repository can live. I'll create a new folder, and I will name it Git Test. You can name the folder whatever you'd like. Now within Git Test, I'll right-click and create a new file. I'll call it untitled.ipynb, leave it as is, and create the new Jupyter notebook. Let's add a line here. And then save the file using Control-S. Now, let's click on the menu at the top left of the notebook panel. Then click Compute, then click Open Terminal. This option will be grayed out for you if your compute instance is not active. In that case, make sure to start your compute instance, wait for it to finish starting, and come back to this menu. Now, within the folder we've just created, run the command git init, I-N-I-T, and press enter. By initializing our repository, We can now track changes and create a history of the development process, making it easy to collaborate and revert changes if needed. Now, let's stage our files for commit and make our first commit with a meaningful message. Committing code is a crucial part of version control. First, we will stage all files in this folder using git add space period and then press enter. You may get an error message calling out dubious ownership. This is because our directory does not exist on the compute instance itself, but elsewhere in Azure and is simply mounted to our compute instance. Run the command listed below to add an exception, then run git add period again. I will copy the command using Control-C, then press Control-V and enter to run the command. Then I will press the up arrow twice to bring up the git add command that I ran earlier and press enter. Now, let's commit the staged files with a clear descriptive message using git commit-m. I will say git commit-m and then in quotes, initial commit. And then press enter. If this is your first time using Git on this compute instance, or you don't have Git set up globally, you'll need to configure your email address and name. Do so using the provided commands, then run git commit again. I'll copy the first command using Control-C and Control-V to paste it. Before I press enter though, I will replace it with my email and then press enter. I will do the same for my name. Now that I've configured my email and name, I will try to commit the message again. And this time my commit goes through. In this video, you've set up and managed a Git repository for your machine learning project. You saw how to initialize a repository, organize files into a clean structure, and commit changes. Now it's time to put this knowledge into action. Create a Git repository for your own machine learning project, organize your files, and commit changes. Imagine losing hours of work because a bug you can't track down overwrote crucial code, or worse, because you accidentally deleted it. In this video, I'll show you how to go from local commit to full remote setup on GitHub, all the way to setting up branches for safe, efficient development. Let's dive in and make sure your hard work is protected and versioned right from the start. By the end of this video, you'll be able to commit your code with meaningful messages, push your repository to GitHub, and set up branches for effective version control in collaborative and ongoing development. Committing your code with meaningful messages ensures that every change you make is recorded, making it easier to track progress and roll back if necessary. Once we've committed the changes locally, it's time to push the repository to a remote platform such as GitHub. This makes your code accessible and backed up in the cloud. We'll create a new repository on GitHub using their web interface. Open a new tab and go to github.com and sign in or sign up for a new account. I'll create a new repository with the same name as my directory in Azure. I'll call it git test. You can use a different name, but using the same name simplifies things. Then I will click create a new repository, making sure to keep it private. Then I will click HTTPS here and copy this URL. I will go back to my terminal and type git remote add origin space and then paste the URL I just copied. Now we need to authenticate with GitHub. Visit this link. The link will be provided for you to access the script to set up the GitHub CLI. I've copied this link and I'm pasting it in a new tab. You can also pause the video here to copy the link manually, to type the link out manually in your web browser and visit it. Here, I will copy the install script for Linux, since our compute instance runs Linux, and paste it in the terminal, then press enter to run it. When the script finishes, I will type gh space auth space login and then press enter. I will select github.com. GitHub.com is already selected, so I will press enter. I want to connect over HTTPS, so I will press enter. And I want to log in with a web browser, so I will press enter. Now, let's click this link to open the GitHub authentication in a new tab. I will continue to sign in as Coursera AIML. I will continue to sign in to my GitHub account. Then I will go back to the terminal and copy the one-time code to paste into my web browser. Then I will click Continue. Then I will click Authorize GitHub. I will re-enter my password to confirm. And now my device is connected. Back in the terminal, I will press enter, which will attempt to open the link in a web browser, but since there is no web browser on this compute instance, the attempt to open the browser will fail. However, the attempt to authenticate will succeed, and we have now logged in as Coursera AIML to our GitHub account. Now we will push the code to GitHub using git space push space dash u space origin space master, making sure to spell origin correctly, and then press enter. Finally, we'll set up version control for ongoing development using branches. Branching allows us to work on new features without affecting the main codebase until changes are ready. Check out a new branch for development using git checkout -b. Make sure that you have supplied a name for your new branch. Let's call this feature-branch. Then press enter. Now, let's make some changes to our Jupyter notebook. Let's say Git is a very useful tool. And then press Ctrl+S to save our notebook. Returning to the terminal, we will do git space add space dot to add any new files that may have been created. Then we will type git commit space -m space and then our commit message, which in this case will be added details on Git to the Jupyter notebook, and close with a quote and press enter. Now, we will return to the master branch using git checkout master. and then merge our branch using git space merge space feature dash branch, and then press enter. Using branches allows for parallel development. You can test new features, fix bugs, or make updates without affecting the stable version of the project until everything is ready. In this video, we covered the basics of using Git and GitHub to manage and protect your code. You learned how to commit with clear messages, push your work to a new GitHub repository, and set up branches for safe, organized development. Now, you have the tools to track changes, collaborate, and ensure a stable project. Try it yourself. Set up a GitHub repo, commit with clear messages, and create a branch for new features.
What if you could build high-performing machine learning models with far less data? What if the secret lies in leveraging knowledge that's already been learned? Welcome to this lesson on transfer learning. In this video, we'll explore how transfer learning can revolutionize your AI/ML projects by leveraging a pre-trained model. You'll learn the key concepts, practical applications, and best practices to make the most of this powerful technique. By the end of this video, you'll be able to define the concept of transfer learning and its core principles. You'll be able to describe the benefits of leveraging pre-trained models and AI/ML workflows. You'll be able to discuss practical applications of transfer learning in various domains. Transfer learning is one of the most powerful techniques in modern AI/ML. It allows us to take pre-trained models and fine-tune them for new tasks, reducing the amount of labeled data and computational resources required. Let's break down how transfer learning works. First, we'll explore foundational concepts like feature extraction and fine-tuning. Then, we'll discuss how to select the right pre-trained model for your use case. For instance, BERT and GPT excel in NLP tasks, while ResNet is widely used for image recognition. Transfer learning works by training a model on a large data set to capture general features. These pre-trained models act as a starting point and can be adapted to new tasks with minimal additional training. Transfer learning allows pre-trained models to adapt to these new tasks by leveraging their previously learned patterns in information. For example, a model like ResNet, which has been trained on millions of images, already knows how to recognize basic features like edges or textures. When applied to a specific task, such as a medical image analysis, you can fine-tune ResNet with your dataset to detect abnormalities, like tumors, for example. Fine-tuning ensures that the model performs optimally for your specific use case, while saving you time and computational resources. Here's a tip to make sure you can follow this best practice. Select a pre-trained model that aligns with your domain. For example, ResNet for image tasks or GPT for text. Prepare your dataset carefully, ensuring it's clean and relevant to the task. During fine-tuning, monitor key metrics to ensure the model adapts effectively without overfitting. One challenge in transfer learning is ensuring the pre-trained model generalizes well to your data without losing its original strengths. By freezing or partially freezing certain layers, you can retain valuable pre-trained knowledge while refining other layers for your specific task. Follow this tip to ensure a smooth implementation. Try to freeze the early layers of the model to preserve that foundational knowledge and focus on fine-tuning the later layers for domain-specific improvements. Finally, testing is crucial when implementing transfer learning. Once your model is fine-tuned, test it with diverse datasets to ensure it generalizes well across various examples. Consider edge cases and ensure the model performs consistently in real-world scenarios. Here's a tip to help you make sure you adhere to this best practice. Try to validate your fine-tuned model using a mix of your task-specific dataset and an external dataset. This ensures robustness and prevents overfitting to a narrow set of examples. In this video, we explored the transformative power of transfer learning in AI ML workflows. We emphasized the importance of selecting the right pre-trained model for your domain, understanding key processes like feature extraction and fine-tuning. We also leveraged transfer learning to reduce the need for extensive labeled data and computational resources. We discussed how pre-trained models like ResNet for image recognition or BERT for NLP can be fine-tuned to solve new tasks with efficiency. By reusing learned patterns and adapting models to specific tasks, you can save time, improve accuracy, and overcome challenges, even with limited data. Now, take what you've learned and apply it to your own projects. Start by identifying areas where pre-trained models could accelerate your work, fine-tuning them for your unique challenges, and exploring how transfer learning can maximize efficiency and performance. Remember, transfer learning is all about leveraging existing knowledge to create impactful solutions.
Are you ready to master transfer learning and see it in action? In this walkthrough, we'll guide you step by step through implementing and fine-tuning a pre-trained model to solve a practical problem. Let's dive in. By the end of this video, you'll be able to load and pre-process a dataset for transfer learning, use a pre-trained model for a new classification task, and analyze and evaluate the performance of the fine-tuned model. Let's begin by going in our web browser to ml.azure.com. I will sign in if prompted, and then I will enter my workspace. Here, I will go to the Notebooks section and click the Add Files button, and then Create New File to create a new Jupyter Notebook. Once the file has been created, I will collapse the File Explorer to make it easier to view my code. I will also make sure that my compute instance is attached and running, and that I have selected the Python 3.8 Azure ML kernel. Now, let's prepare our dataset. For this walkthrough, we're using CIFAR10, a well-known image classification dataset containing 10 classes, such as airplanes, cars, and birds. Watch as I load the dataset, normalize the pixel values, and split it into training, validation, and test sets. I will copy and paste this code into my Jupyter Notebook. The same code will be made available to you to copy and paste. Then I will press Shift and Enter to run the code and proceed to the next cell. Here, we implement TensorFlow, the CIFAR10 dataset, toCategorical, and train test split from scikit-learn. Then we will load and preprocess the dataset by calling CIFAR10.loadData and entering that data into xtrain, ytrain, and xtest and ytest. We will convert ytrain and test to categorical, and then we will normalize the pixel values by dividing them by 255. Now we will split the training data into training and validation sets, and then we will display dataset information. Here we print the number of training samples, validation samples, and test samples. Here we have 40,000 training samples, 10,000 validation samples, and 10,000 test samples. At this point, when loading TensorFlow, you may see an error message. This one indicates that the binary was compiled without the following CPU instructions. You can ignore this error message. We've now split the dataset into 3 sets, ready for our training and evaluation steps. Next, we'll load MobileNet v2, a lightweight yet powerful pre-trained model. This model has been trained on millions of images, making it a great candidate for transfer learning. I'll copy and paste this code. The same code will again be made available to you to copy and paste. Then I will press Shift Enter. Here, we will import MobileNet. We will load the MobileNet model and display a summary of the model. Then, we will inspect the layers of this neural net model and find the first layer with weights. For the layer with weights, we will print its name, we will get its weights, and we will visualize them too. Else, we will print error messages saying that we cannot visualize the weights or that there are no layers with weights found in the model. Here, we see that we are using MobileNet v2 1.00.224. Here, we can see the layer type, its output shape, the number of parameters, and which layer it is connected to. We've frozen the base layers to retain the knowledge from pre-training and added new layers specific to our CIFAR 10 classification task. Now, let's train our new model. This will fine-tune the added layers while preserving the pre-trained features. I will copy and paste this code. The same code will be made available to you to copy and paste. Again, I will press Shift-Enter to run the code and start the training. Our training is now complete. Let's take a look at the output. We can see that our final validation accuracy is 0.33. Now let's see how our model performs on the test set. Evaluating our model helps us understand its accuracy and reliability. I will copy this code and paste it into my Jupyter notebook. The same code will be made available to you to copy and paste. Again, I press Shift-Enter to run the code and proceed to the next cell. Here, we call model.evaluate on the test set, and then print the resulting test accuracy. We'll also analyze feature maps from an intermediate layer. And finally, we will display the feature map dimensions. We can see that the accuracy is the same as it was before on the validation set, 0.33. Finally, let's visualize the training and validation accuracy to ensure our model was learning effectively. I will copy and paste this code and make it available to you to copy and paste. Here, we will define a baseline model, and then we will compile and train the model, and then evaluate the baseline model and summarize the comparison. Here, our baseline model is a sequential neural net that consists of a convolutional layer, max pooling layer, flatten, and 2 dense layers. This differs from our previous model, which used a base model and then added some layers to it. Let's see how these approaches compare. The training on our baseline model has completed. Let's take a look at its accuracy. Here, we see the validation accuracy steadily improving over time. The baseline model's test accuracy is 0.61, whereas the transfer learning's test accuracy was only 0.33. Transfer learning allowed us to leverage the strengths of MobileNet v2 while fine-tuning it for our specific task. This saved us significant training time and resources, but didn't achieve the same accuracy as the baseline model. Training the hyperparameters with Azure ML and Azure Machine Learning could help us increase the accuracy of this transfer learning model, as could using a model other than MobileNet v2. The other advantage of transfer learning is also difficult to see in this example because of the small size of the models. In dealing with very large models such as LLMs, it becomes impractical to train new models from the ground up to handle new tasks or learn new information. This is an example where transfer learning can maintain accuracy while decreasing training time and resources. Imagine applying this approach to your own projects in fields like healthcare, e-commerce, or beyond. Here, let's one more time compare the training and validation accuracy of our models, the baseline and the one we used transfer learning on. I will paste this code, press Shift-Enter to run it. And here we see that the baseline validation accuracy does not steadily improve, but the training accuracy improves quite a bit. In comparison, for the transfer learning model, both the validation and training accuracy remained low throughout the training process. By following this walkthrough, you've seen how transfer learning enables us to repurpose powerful pre-trained models for new tasks, saving time and resources while achieving great results. Keep experimenting and exploring the vast possibilities of transfer learning. Try applying transfer learning with a different dataset or pre-trained model. Reflect on how this technique could be used in your own projects and share your findings with others.
What if you could train machine learning models collaboratively without ever sharing sensitive data? What if the key to privacy-aware AI lies in keeping data where it belongs, and that's on your device? Welcome to this lesson on federated learning. In this video, we'll uncover how federated learning is transforming the way we approach data privacy and machine learning. You'll discover its key concepts, practical applications, and best practices for leveraging this innovative technique. By the end of this video, you'll be able to define the concept and principles of federated learning. You'll be able to identify the benefits of federated learning in preserving data privacy. You'll be able to discuss real-world applications of this technique. So what is federated learning? Let's begin with our definition. It's, at its core, a decentralized approach to training machine learning models where data remains on the device that generates it. Instead of sending data to a central server, the model is sent to individual devices, trained locally, and then updated through aggregated insights. This ensures that sensitive data never leaves the user's device, addressing key concerns around privacy and security. Federated learning begins with a central server that initializes the process by distributing a global model to all participating devices. Each device trains the model locally using its own dataset, adjusting parameters based on its specific data. These updated parameters are sent back to a central server, which aggregates them to refine the global model. This cycle of local training and parameter aggregation is repeated iteratively until the global model achieves the desired level of performance. Federated learning enhances privacy by keeping data on individual devices. It reduces bandwidth usage by transmitting only model parameters, and it enables personalized experiences by tailoring models to user-specific data. Here's a great example: the smartphone. Companies like Google use federated learning to improve services like keyboard suggestions by training models directly on user devices. This ensures personalized experiences without sending private typing data to the cloud. Federated learning faces challenges such as handling diverse data distributions across devices, ensuring secure and efficient parameter aggregation, and balancing computational loads on resource-constrained devices. Federated learning represents a significant shift in how we think about collaborative machine learning. By keeping data local, it paves the way for secure and efficient AI applications across industries. And as we continue to explore its potential, federated learning could redefine the future of what we like to call privacy-aware artificial intelligence. Take a moment to think about industries or applications where federated learning could make a difference. How could this technology transform the way we approach data privacy and AI? Share your thoughts, share your ideas. In this video, you learned about the principles of federated learning. You learned about privacy enhancement by keeping data local. You learned about benefits like bandwidth efficiency and personalization. And we explored real-world uses, for example, how Google uses smartphone improvements. Now, let's take what you've learned and apply it to your own projects. explore how federated learning can improve privacy and efficiency in your AI workflows. Start by identifying scenarios where decentralized data training could benefit your applications while addressing challenges like data diversity and resource constraints. Remember, federated learning is about combining collaboration and privacy to create innovative, secure AI solutions. What if you could combine the strengths of multiple machine learning models to create a system that's more accurate? Let's talk about ensemble methods. In this video, we'll explore how ensemble methods can elevate your machine learning projects by leveraging the power of multiple models. You'll learn the key concepts, practical techniques, and real-world applications to harness this powerful approach effectively. By the end of this video, you'll be able to describe the concept and advantages of ensemble methods. You'll be able to identify key ensemble techniques such as bagging, boosting, and stacking. You'll also be able to discuss real-world applications of these ensemble methods. Ensemble methods in machine learning involve combining the predictions of multiple models to create a more accurate and robust final prediction. The idea is simple. By leveraging the strengths of individual models while minimizing their weaknesses. This approach often outperforms standalone models by reducing overfitting, increasing stability, and improving generalization. First up, let's talk about bagging, or bootstrap aggregating. Bagging trains multiple models on different subsets of the data, generated through bootstrapping, and combines their predictions, often using averages or majority voting. Random forest is a classic example of bagging. Next up, let's talk boosting. Boosting focuses on sequentially trained models, where each subsequent model corrects the errors of its predecessor. Gradient boosting machines, GBMs, and AdaBoost are popular boosting algorithms. Then there's stacking. Stacking involves training multiple models and then using another model, often called a meta-learner, to combine their outputs. This hierarchical approach can capture complex patterns that individual models might miss. An example is combining logistic regression with decision trees and neural networks for more robust prediction. Ensemble methods enhance the accuracy of things like disease detection by combining predictions from various algorithms. For example, bagging improves cancer detection by aggregating results from different classifiers. Ensemble methods are known to reduce overfitting, increase stability, and improve generalization. They also handle noise and outliers effectively, making them ideal for real-world applications where data imperfections are all too common. While ensemble methods are powerful, they can increase computational cost, require careful design, and can suffer from redundancy if models are too similar. However, thoughtful evaluation can help mitigate these challenges. Ensemble methods demonstrate the power of collaboration, even in machine learning. By combining the strengths of multiple models, they offer a reliable path to enhanced performance and robustness. Whether you're building predictive models or tackling complex data challenges, ensemble techniques are an invaluable tool in your machine learning toolkit. In this video, we explore the transformative power of ensemble methods in machine learning. We discussed how techniques like bagging, boosting, and stacking combine the strengths of multiple models to create more accurate systems. We emphasize the importance of choosing the right ensemble approach for your problem, understanding key techniques like random forest or gradient boosting. We leveraged these methods to improve performance while addressing challenges such as overfitting or data imperfections. By combining the outputs of individual models, ensemble methods enhance predictive accuracy, increase generalization, and provide a powerful tool for tackling complex machine learning challenges. Now, let's take what you've learned and apply it to your own projects. Start by identifying areas where ensemble methods could improve your model's accuracy. Experiment with techniques like bagging, boosting, or stacking to tackle complex challenges and enhance predictive performance. Remember, ensemble methods are all about combining those strengths to create impactful and reliable solutions.
Have you ever wondered how combining multiple models can elevate your machine learning performance? In this walkthrough, we'll explore the practical implementation of ensemble methods like bagging, boosting, and stacking, highlighting their strengths and how they work in real-world scenarios. Let's get started. By the end of this video, you'll be able to list the implementation steps for key ensemble techniques, integrate bagging, boosting, and stacking into machine learning workflows, and discuss real-world applications and their impact. Let's start with bagging. Bagging, or bootstrap aggregating, works by training models on bootstrapped subsets of the dataset. To demonstrate this, let's go to ml.azure.com in our web browser. I will sign in if prompted, and then enter my workspace. Then I will go to the Notebooks section, click Add Files, create New File, and create a new Jupyter notebook. Then I will collapse the File Explorer, make sure that my compute instance is running and attached, and make sure that I've selected the Python 3.8 Azure ML kernel. Going back now to bootstrap aggregating or bagging, let's discuss an example. For example, random forests extend bootstrap aggregating technique by introducing random feature selection at each split, making the ensemble even more diverse. Here's how it works in Python. I will copy and paste this code. The same code will be made available to you to copy and paste. Then I will press Shift and Enter to run the code and proceed to the next cell. Here, we load a dataset from scikit-learn, and we train a random forest classifier on the model. Then we evaluate the model. Now, let's move to boosting. Boosting focuses on reducing bias by sequentially training models, each correcting the errors of the previous one. Gradient boosting machines are a powerful implementation of this technique. Here's an example. I will copy and paste this code, and again, you can also copy and paste it. Then press Shift Enter to run the code and proceed to the next cell. Here, we import a gradient boosting classifier from scikit-learn, and then train it, and then evaluate it. Like we can see here that our boosting accuracy is 1.00 or 100%. Finally, let's discuss stacking. Stacking combines predictions from multiple models using a meta-learner. This approach is highly effective for capturing complex relationships in data. I will copy this code and make it available to you to copy and paste. Then I will press Shift and Enter to run the code and see that my stacking accuracy is also 100%. Here, we define two base models, a decision tree classifier, and SVC. Then we define the meta-learner, which in this case is a logistic regression model, and then we create the stacking model, which is a stacking classifier. We train it on our data and evaluate it here. Each ensemble method has its unique applications. Bagging excels at reducing overfitting in noisy data sets. Boosting is ideal for improving sensitivity to complex patterns, and stacking combines diverse models for maximum predictive power. In this walkthrough, we implemented three powerful ensemble methods. We learned how to implement bagging, boosting, and stacking. The perfect accuracy results, or 1.00, observed for stacking, bagging, and boosting are due to the limited dataset size and controlled lab conditions. Real-world datasets, which are larger and more complex, typically yield more realistic accuracy scores. These lab results should therefore be interpreted with these constraints in mind. As you work on your projects, consider which technique best suits your data and goals. Ensemble methods showcase the power of collaboration, even in machine learning. Try implementing these techniques in your own dataset. Reflect on the results and think about how ensemble methods can enhance your machine learning solutions. Happy coding!
Welcome to this lesson on generative AI, or GenAI. As you're well aware in taking this course, generative artificial intelligence is fast becoming the most popular and game-changing shift in everything from workflow to artistry. Tools like large language models to generative image and video tools represent sea changes in the way we do everything from education to human resources to marketing. In this video, we'll explore how generative AI is transforming the way we solve problems and create solutions. You'll learn the key concepts, practical applications, and the limitations to watch out for as we navigate this exciting frontier in artificial intelligence. By the end of this video, you'll be able to describe the current capabilities and limitations of generative AI. You'll be able to discuss practical applications driving real-world change. And you'll be able to distinguish between what's hype and what's a genuinely transformative in AI's current trajectory. Generative AI refers to models capable of creating content, from text and images to music and video. These systems, powered by advanced deep learning architectures, such as LLMs for text generation and diffusion models for image, animation, or frame interpolation, utilize concepts like transfer learning and fine-tuning to generate outputs that are both coherent and contextually relevant. Built upon foundational techniques like neural networks and ensemble learning, these models excel by leveraging vast data sets to identify patterns and relationships. While often celebrated for their creative outputs, GenAI also plays a critical role in fields like medicine or engineering, enabling transformative advancements in diverse domains. GenAI is already transforming industries. In healthcare, it aids drug discovery and accelerates clinical trials while safeguarding data privacy. In entertainment, it creates everything from personalized video game characters to dynamic storylines and drafts for films and novels. In education, AI-powered tutors and content creators are making personalized learning globally accessible. The promise of GenAI is vast, but not everything is revolutionary. It excels in automating repetitive creative tasks and offering new tools for innovation. However, it can struggle with factual accuracy, otherwise known as a hallucination. Further, use of GenAI also involves a series of complex ethical considerations that must be taken into account. GenAI is designed to complement human expertise, not replace it. Generative AI isn't just hype. It's a powerful tool that's reshaping how we create, learn, and innovate. But as with any transformative technology, its true potential lies in how we choose to use it. So what role will you play in this Gen AI-powered future? In this video, we explore the transformative power of generative AI in modern workflows. We discussed how advanced models, such as GPT for text generation or diffusion models for image generation, are reshaping industries with creative and practical implications both. We emphasized the importance of understanding generative AI's capabilities and limitations, such as hallucinatory text, its role in automating repetitive tasks, and its potential for personalized solutions in areas like healthcare, education, or entertainment. Now, take what you've learned and apply it to your own projects. Explore how generative AI can enhance your work by automating tasks, creating personalized solutions, or driving innovation in your field. Identify opportunities to integrate models like Copilot or diffusion models into your workflows and consider how they help address challenges or unlock new possibilities. With these new tools at your disposal, what kind of future will you build? What if you could create text, images, or music effortlessly with AI that understands your needs? What if this technology could reshape industries and drive unprecedented innovation? Welcome to this lesson on generative AI models. In this video, we'll explore how generative AI, or GenAI, models are built, how they work, and the transformative impact they're having across industries. You'll learn about their key concepts, practical applications, and the challenges and opportunities they bring to the table. By the end of this video, you'll be able to describe the foundational types of generative AI models, explain how these models are both structured and trained, and discuss their real-world applications and impact. Generative AI models are machine learning architectures designed to create new content, such as text, images, audio, or video. These models work by learning patterns and structures from vast data sets during the training process. By leveraging techniques like transfer learning and optimization, they generate outputs that are both coherent and contextually relevant. Transformers, for example, excel at processing sequential data like text. They use self-attention mechanisms to capture intricate relationships within data sequences, enabling human-like language generation. Generative adversarial networks, or GANs, use a competitive framework of generator and discriminator to create realistic outputs. VAEs encode data into a latent space and decode it for variations, ideal for image generation or anomaly detection. Diffusion models reverse noise to generate high-quality images, perfect for design applications, for example. Training GenAI models involves exposing them to large, high-quality data sets. Techniques like unsupervised learning allow models to understand data structures without explicit labels. Optimization methods like gradient descent minimize errors, while transfer learning enables quick adaptation to specific tasks. Generative AI models are revolutionizing industries. In content creation, LLMs streamline writing workflows. GANs and diffusion models enable artists to explore new creative directions. VAEs support anomaly detection in medical imaging for earlier diagnoses, and transformers can enhance gaming experiences by enabling dynamic and personalized content. Generative AI models are more than just algorithms. They're tools that empower creativity, innovation, and problem solving. Understanding their structure and capabilities opens the door to endless possibilities in shaping our future. So here's a tip to make sure you can follow this best practice when choosing a generative AI model. Choose one that best fits your use case. For instance, LLMs for text generation, GANs for realistic image creation, or diffusion models for high-quality visual output like animation. Ensure that your training data is clean, diverse, and relevant to the task to maximize the model's overall effectiveness. One challenge with generative AI is balancing creativity with control. By fine-tuning specific parameters or adding constraints, you can guide the model to produce outputs that align with your goals while maintaining its flexibility and generative strengths. In this video, we explored the transformative power of generative AI in shaping modern workflows. We discussed how advanced models like GPT for text generation, GANs for creating realistic images, and diffusion models for high-quality visuals are revolutionizing various industries. We emphasize the importance of understanding the unique capabilities and training processes of these models, from leveraging self-attention mechanisms in a transformer, for example, to the competitive framework within a GAN. By effectively utilizing these models and adapting them to your specific tasks, you can drive innovation, enhance productivity, and address complex challenges across diverse domains. Now, take what you've learned and apply it to your own projects. Start by identifying how generative AI models could enhance your work, whether by automating repetitive tasks, generating creative content, or solving complex challenges. Experiment with models like GPT or GANs, tailoring them to your unique needs, and explore how they can drive innovation and productivity in your domain. Remember, generative AI is all about unlocking new possibilities and creating impactful and forward-thinking solutions.
Generative AI models are reshaping industries with their ability to create realistic and innovative content. In this walkthrough, we'll build and analyze a simple generative model step by step. Let's see how these models can power applications like chatbots, creative tools, and automated reports. By the end of this walkthrough, you will load and pre-process a text dataset for generative modeling, tokenize and pad sequences to prepare data for training, build and train an LSTM-based generative text model, and generate text from a seed prompt using the trained model. Let's start by going to Azure Machine Learning. In a web browser, I'll navigate to ml.azure.com and press Enter. I will sign in if prompted, and then enter my workspace. In my workspace, I will click on the Notebooks section and click Add Files, and then Create New File to create a new Jupyter notebook. Now, I will collapse the File Explorer to make my code easier to view. I'll also make sure that my compute instance is attached and running. And then I will make sure that I've selected Python 3.8 Azure ML as my Azure Python kernel. We'll start by accessing a dataset of English quotes from Hugging Face's datasets library. This is an excellent resource for real-world datasets. First, ensure you've installed the datasets library by running pip install datasets. You can do this in Jupyter Notebooks by prepending your command with an exclamation point. Then I will press Shift and Enter to run the code and automatically proceed to the next cell. Here, we can see that the requirements are already satisfied and that we already have the datasets library installed. Now, I will copy and paste this code. The same code will be made available to you to copy and paste. Here, we will load the English quotes dataset and then combine all the quotes into a single text corpus. Then we will prepare this corpus for tokenization and model training. Next, let's tokenize the text to convert words into numerical representations and pad the sequences to ensure uniform input length. This step ensures that our dataset is structured for the LSTM model to process efficiently. I will copy and paste this code, which again will be made available to you to copy and paste. Pressing Shift and Enter runs the code. Here, we see an error message from TensorFlow that we can safely ignore. And in this code, we have imported tokenizer from TensorFlow, tokenized our data, and padded the sequences. Now, we'll define an LSTM-based generative model. LSTMs are excellent for capturing sequential patterns in text data. This model learns to predict the next word in a sequence, training on our tokenized dataset. I will copy and paste this code and press Shift Enter to run it. Here, We will define this model as a sequential neural net, and then we will compile the model. After the model has finished compiling, we will prepare input and target data, and then train the model. This next step may take some time. We've now finished training our model. Let's test our trained model by giving it a seed prompt and generating a 50-word continuation. I'll copy and paste this code and make it available to you to copy and paste also. Then we'll press Shift-Enter to run the code. The model generates text by predicting one word at a time. Let's wait for some text to appear and then discuss the results. Here, the model has generated text by predicting one word at a time. That is, given the previous word, it chooses what it thinks the most likely next word is, and repeats this process until we've generated 50 words. Unfortunately, the text it's generated is not coherent, but this is because we used few training epochs. We trained for only one epoch. It is also because we are training and inferring on a CPU with limited resources, and because we didn't properly clean the data prior to training. Note the inclusion of quote marks in the output. You can try running this again, but this time using a GPU instance, or applying what you learned in other courses to clean the data, or using more training epochs to produce more coherent output. Generative models like this one have endless possibilities. They can power chatbots for customer service, generate creative content for entertainment, or automate reports in business settings. In this walkthrough, we accessed and loaded a dataset of English quotes, prepared the data through tokenization and padding, built and trained an LSTM-based generative text model, and generated text based on a seed prompt. Now it's your turn. Try adapting this walkthrough to a dataset of your choice and experiment with different model architectures. See how generative models can elevate your projects and let your creativity drive the next breakthrough in generative AI.
What if you could harness the power of cutting-edge machine learning techniques to tackle challenges that once seemed impossible? What if these methods could revolutionize industries and drive innovation across the globe? Welcome to this lesson on advanced machine learning techniques. In this video, we'll explore how techniques like transfer learning, federated learning, ensemble methods, and generative models are transforming the world of artificial intelligence. You'll learn their key principles, real-world applications, and how to leverage them to solve complex problems effectively. By the end of this video, you will be able to describe the significance of advanced machine learning techniques in modern AI. You'll be able to explain how these methods enhance capabilities across various domains. And you'll be able to recognize the opportunities these techniques create for both innovation and growth. Advanced machine learning techniques such as transfer learning, federated learning, ensemble methods, and generative models are not just theoretical advancements. They are practical tools transforming industries. These methods allow AI systems to tackle tasks that were previously thought unattainable, enabling breakthroughs in areas such as healthcare, finance, retail, and the creative industries. For example, transfer learning enables models to leverage knowledge from one domain and effectively apply it in another, making it invaluable in fields with limited labeled data. Federated learning addresses the growing need for privacy, preserving AI by decentralizing data processing, empowering industries like healthcare to collaborate without compromising confidentiality. Ensemble methods enhance predictive accuracy and robustness by combining multiple models, making them indispensable for applications like fraud detection in finance and personalized recommendations in e-commerce. Meanwhile, generative models revolutionize content creation, from producing realistic imagery for films to generating synthetic medical data sets that accelerate innovation in drug discovery. These techniques are critical not just for their performance improvements, but also for their scalability and adaptability. They empower organizations to extract meaningful insight from massive data sets. They help automate complex processes, and they create innovative solutions to real-world challenges. For example, consider a healthcare application where federated learning enables hospitals in different locations to collaboratively train a model for early cancer detection. By keeping patient data localized and only sharing model updates, this approach preserves privacy while improving our diagnostic accuracy. The resulting model identifies subtle patterns in imaging data that might otherwise go unnoticed, offering patients earlier and more effective treatments. Advanced machine learning techniques matter because they bridge the gap between theoretical potential and real-world impact. By harnessing these methods, we can build smarter, more efficient systems that drive progress across every sector. The question is, of course, how will you use them to innovate in your field? In this video, we explored the transformative power of advanced machine learning techniques in modern artificial intelligence. We discussed methods like transfer learning, federated learning, ensemble approaches, and generative models, highlighting their ability to address complex challenges across industries. We emphasized the importance of selecting the right technique for your specific use case, understanding key concepts like privacy-preserving collaboration in federated learning and predictive accuracy in ensemble methods. By leveraging these techniques effectively, you can drive innovation, improve efficiency, and solve real-world problems with smarter, more adaptable AI systems. Now it's time to take what you've learned and apply it to your own projects. Start by identifying challenges in your field that could benefit from an advanced machine learning technique, whether it's improving accuracy with ensemble methods, ensuring privacy with federated learning, or creating innovative solutions with the assistance of a generative model. Experiment with these techniques, adapt them to your specific needs, and explore how they can drive efficiency, scalability, and innovation in your work. Remember, at the end of the day, advanced machine learning is all about transforming knowledge into impactful, real-world solutions. Artificial intelligence is transforming industries, but of course, with great power comes great responsibility. As AI systems evolve, ethical considerations like transparency, accountability, and privacy are critical to ensuring AI benefits society while minimizing harm. In this module, we'll explore the scope of ethical issues in AI, grounded in practical frameworks that bridge theory and real-world implementation. By the end of this video, you'll be able to explain the importance of transparency, accountability, and privacy in AI systems. You'll be able to identify the key components of a structured framework for addressing ethical considerations in AI. And you'll recognize the dynamic nature of the ethical landscape and the need for ongoing monitoring and compliance. Further, you'll be able to explain how ethical principles can be integrated into real-world AI development and deployment. Ethical considerations in AI are not just theoretical. They directly impact how AI systems are developed, deployed, and trusted. Transparency ensures AI decision-making is understandable, enabling trust and effective interactions. Accountability establishes mechanisms to hold developers and organizations responsible for AI outcomes. Privacy protects sensitive data and ensures compliance with government regulations. To integrate these principles into practice, we'll follow a structured framework. We'll begin with stakeholder analysis. We have to identify all parties affected by the AI system and understand their respective needs. Then we'll move on to risk assessment. We'll evaluate potential challenges and develop strategies to mitigate them. Then there's continuous monitoring. will need to regularly assess system performance and ethical implications post-deployment. We'll also need to look at compliance alignment. We need to ensure adherence to laws and industry standards, which are both ever-changing, in order to maintain integrity and trust. It's important to note that the ethical landscape of AI is highly dynamic and shaped by technology, culture, and law. While this module reflects current best practices, ongoing learning and adaptability are essential to address new challenges as AI continues to inevitably evolve. Now that we've explored the foundational principles of ethical considerations in AI, take a moment to reflect on how transparency, accountability, and privacy can shape the way you approach your AI projects. In conclusion, ethical considerations like transparency, accountability, and privacy are foundational to AI development and should never be treated as nothing but a mere afterthought. By applying a structured framework, you can ensure your AI systems align with societal values and expectations, both building trust and creating positive impacts.
One of the biggest problems that we want to solve in the world of talent is predicting who is going to make a great hire. Traditionally, you have probably applied for jobs before. You submit your application, fill out a really long form, typing your resume 1,000 times, and it goes into some black box. Over time, in the organizations that I partner with, we started to wonder, can we do this more efficiently? What if we can predict who is going to make a great hire based on characteristics, based on their experiences, and perhaps some sort of matching between the job description and their skill sets? Sounds like a great problem for ML to solve, and it is. But over time, we've also discovered that it's not as easy as it seems. In fact, in one of the organizations, we started doing this in-house, meaning we took a lot of internal candidates who may be up for the next role, could be a promotion, maybe not. And then we had our job descriptions, so we were trying to make a match between the skill sets required on those job descriptions and what the person is able to do based on our guesses from their experience, from their education, from their training, and so on. And what we had discovered was that the model can do a decent job in matching once it's decoding these resumes and experiences and the job descriptions. But in practice, do you want someone who is a 100% match for the job description? Or do you want someone, again, thinking about these as internal candidates, do you want someone who is perhaps a 70 to 80% match for the skill sets required on the job description? Because there will be room to grow, there will be room to learn, and that's the point of internal mobility anyways, right? So what we discovered was that it was practically easy to find matches and even put them into different categories of a strong match, medium match, and so on. But then when it comes to decision making and actually putting this data, these matching results to practice, there's a lot of issues with getting hiring managers to see that there isn't actually an optimal or accurate or a best number for that matching. It could be 80% for some organizations, maybe 60% if you can get up to speed really quickly in a new role. Or perhaps it's 95% because it impacts safety for customers and you'll have to have someone who is actually able to do almost 100% of the job already coming in. So all of that, we started to realize that this is actually a business decision and not so much of a technical decision on the matching being optimal. So I share that as an example because oftentimes we think about model metrics, right? Whether it's performance or even for monitoring afterwards, and we want to strive for, getting close to 100% as possible. But there are lots of times in reality where 100% is actually not what you want.
What does it mean to create AI responsibly? In this video, we'll explore how defining responsible AI is about more than just avoiding harm. It's about maximizing positive impact while staying aligned with societal value. Responsible AI refers to the development and deployment of artificial intelligence systems in a way that is ethical, accountable, and beneficial to society. By the end of this video, you'll be able to describe the core principles of responsible AI. You'll be able to explain how to apply these principles in development and in deployment, and you'll be able to discuss the need for continuous evaluation in AI systems. At its core, responsible AI prioritizes transparency, making AI systems understandable and interpretable. It also establishes accountability, which establishes clear responsibilities for AI outcomes. Then there's privacy. Responsible AI is all about safeguarding sensitive data and safety, ensuring system reliability and resilience. Unlike reactive approaches, responsible AI integrates proactively, using strategies to align AI systems with both technical excellence and human values. Let's take a moment and break down those key metrics, beginning with transparency. AI systems must be understandable and interpretable. Documentation and clear explanations foster stakeholder and end user trust. Accountability. Clear ownership of AI decisions, well, that's crucial. We need mechanisms for auditing and addressing errors in order to maintain trust. Next, privacy. To maintain responsible AI, we must protect sensitive user data with encryption or anonymization. This ensures compliance with regulations like the General Data Protection Regulation, or GDPR. Then there's safety. Rigorous testing ensures AI systems function reliably in dynamic environments. It's important here to design fail-safe mechanisms in order to help mitigate harm. So why does responsible AI matter? Well, developing responsible AI enhances human capabilities and societal progress while simultaneously minimizing the potential for harm. For example, a healthcare AI tool for diagnostics can improve patient outcomes when developed responsibly. Without transparency, however, trust in its results may falter even if it's accurate. Responsible AI doesn't end with deployment. This is important to remember. Feedback loops are essential for continuous improvement. Regular audits and regular updates ensure systems adapt to new challenges and new societal expectations. In this video, you learned about the definition and key principles of responsible AI, how transparency, accountability, privacy, and safety guide ethical AI development, the importance of continuous evaluation to adapt to evolving challenges. Responsible AI is not just a buzzword. It's actually a guiding framework that bridges innovation and accountability. Reflect on the systems you interact with, or the ones you develop, and think about how you can embed these principles to shape AI and the resultant output for the better. Have you ever wondered how to create AI systems that are both innovative and simultaneously ethical? It's not just about building functional models. It's about following a robust framework that ensures accountability, transparency, and trust. In this video, we'll guide you through a structured approach to responsible AI, breaking down the key principles and how to apply them effectively in your projects. By the end of this video, you'll be able to describe the components of a responsible AI framework. You'll be able to apply this framework effectively throughout the AI lifecycle. Further, you'll be able to discuss the importance of integrating ethical considerations into your technical workflow in order to build systems that align with both societal values and user expectations. Let's begin by answering a simple question. Why does a framework matter? A framework for responsible AI provides a structured approach to addressing ethical, legal, and social considerations in AI development and deployment. It ensures that teams can align technical objectives with societal values. It allows them to build systems that are both reliable and trustworthy, and it helps them avoid unintended harm and simultaneously meet user expectation. Organizations risk creating systems without a framework that fails to perform ethically or effectively. Let's talk about that framework for a moment. First, you want to define objectives and stakeholders. Clearly define the purpose of the AI system. Identify your stakeholders, including end users and decision makers. Establish an ethical alignment amongst these groups to better guide your decision making. Know that it is unlikely any group will ever be 100% in alignment, but it is your job to get as close as possible to this ultimate result. Next, you'll want to conduct risk assessments. Evaluate potential risks at every stage of development. Use tools like risk matrices and scenario planning to identify and mitigate ethical, technical, and operational challenges. Next, you'll want to implement governance mechanisms. Establish clear policies, establish clear roles and responsibilities for managing the AI system and its corresponding outputs. Create structures for reviewing decisions, resolving conflicts, and ensuring compliance with legal standards. You'll also want to ensure transparency. Make AI systems interpretable and their operations understandable, even to the layperson. Document decision-making processes and provide clear, user-friendly explanations. Disclose limitations and potential biases. A real-world example of this would be an AI-powered hiring platform designed to streamline recruitment processes, which illustrates this framework. First, we define objectives and stakeholders. Candidates and HR managers are identified as key stakeholders and their needs are prioritized. Then, risk assessment. Potential exclusion of qualified candidates is addressed by scrutinizing data sources and algorithms. Then there's governance. Policies and regular reviews ensure accountability and compliance both. Backing it up is transparency. Clear explanations about how applications are evaluated help build user trust. A framework for responsible AI is essential for building ethical and effective systems by providing a structured approach to align technical objectives with societal values. In this video, you learned that a responsible framework comprises 4 key components: defining objectives and stakeholders, conducting risk assessments, implementing governance mechanisms, and ensuring transparency. By applying these principles, organizations can address ethical considerations at every stage of development, ensuring their AI systems are trustworthy, accountable, and capable of delivering positive, real-world impacts. A framework for responsible AI bridges the gap between innovation and accountability. By adopting a structured approach, organizations can create systems that not only achieve technical excellence, but also earn the trust of their users. Reflect for a minute on how you can apply these framework principles to your own AI projects. Start with small steps, and eventually you'll build a culture of responsibility at every stage of development. Let's take a step now toward transparency in systems design with explainable AI. By utilizing explainable AI, you can bridge the gap between complex algorithms and human understanding, ensuring that every decision is transparent, trustworthy, and actionable. In this video, we'll explore how explainable AI empowers engineers to build systems that are not only powerful and accurate, but also transparent and trustworthy, revolutionizing industries and enhancing human decision-making. By the end of this video, you'll be able to define what explainable AI is and its foundational concepts. You'll be able to describe the critical role explainable AI plays in AI engineering and deployment. You'll also be able to discuss why explainability matters across technical and ethical dimensions. So what is explainable AI? At its core, it refers to the methods and techniques used to make AI models and their outputs understandable to humans. Unlike a traditional black box model, which produces results without clear insight into the internal decision-making process, explainable AI provides clarity and transparency. For example, in a credit scoring system, explainable AI can break down which factors, like say credit history, income, or outstanding debt, might have influenced an applicant's score, offering insight into why their respective loan application was either approved or ultimately denied. So why is explainable AI important for engineers? Well, at its core, it revolves around trust and adoption. Engineers must deploy AI solutions that stakeholders can trust. After all, if end users can't understand decisions, they may reject the system, even if the result is fully accurate. Then there's debugging and optimization. Explainability helps engineers identify errors and optimize performance. Without insight into model operations, troubleshooting becomes significantly harder. Then we have to talk about compliance and accountability. Regulations like GDPR and the AI Act in the EU require transparency and automated decision-making. Explainability ensures models meet these compliance standards. Let's now talk about ethical responsibility. AI systems impact critical areas, such as hiring or medical diagnostics. Explainable AI helps engineers identify biases and prevent unintended harm. In this video, you learned about what explainable AI is and its foundational concepts. Explainability is essential for building trustworthy and transparent AI systems. It helps engineers build trust and encourage AI adoption, optimize performance and troubleshoot models, ensure compliance with regulations like the General Data Protection Regulation, GDPR. Now that we've explored the fundamentals of explainable AI, take a moment to reflect on how incorporating explainability into your AI systems could transform the way they are developed, deployed, and trusted by users. As we continue through this, you'll gain practical insights and tools to apply explainable AI principles, turning complex concepts into actionable solutions. Imagine using an AI system that determines whether you qualify for a job or whether you qualify for a loan, decisions that could shape your entire future. With clear explanations built into the system, you could understand exactly how that AI makes those decisions, building trust and therefore confidence in the process. We'll explore how explainability transforms AI systems into tools that are not only powerful, but also transparent and trustworthy, reshaping industries and empowering users worldwide. By the end of this video, you will be able to explain why articulating the purpose of an AI system is critical for an engineer. You'll be able to describe how explainability impacts the acceptance, performance, and responsibility of AI solutions. Further, you'll be able to discuss strategies to integrate explainability into AI workflows from the ground up. So let's first address why purpose matters in AI. Every AI system is built with a specific purpose, whether it's diagnosing diseases, optimizing logistics, or enhancing customer experiences. Defining and explaining that purpose is foundational. It ensures that developers, stakeholders, and end users understand the system's role and its limitations. The risk of not articulating purpose can be severe. Even highly accurate systems can be misunderstood or, at worst, misused without clear communication. Engineers play a particular role in explaining this purpose. They bridge the gap between technical and practical aspects of AI systems. They can clear up the jargon and offer clear communication about why a system exists, its goals, and how it functions. This in turn builds trust and accountability, aligns end users with the system's intended use, and mitigates ethical concerns caused by vague or poorly communicated purposes. Here's a great example. An AI used in hiring can foster trust if engineers articulate that its purpose is to screen applicants based on predefined criteria. Without this clarity, misaligned expectations and misuse can arise. So what are the benefits of integrating explainability early on in the process? Well, for the end user, it enables informed decisions about how adopting and applying AI technology affects them. For teams, it encourages collaboration by aligning goals and reducing miscommunication. For compliance officers, it meets regulatory standards requiring clear documentation of the system's purpose. To make explainability integral, it's important to document purpose thoroughly. This includes things like goals, assumptions, and constraints, all the way from the initial design phase. Communicate clearly with non-technical audiences. Avoid jargon. Use accessible language and visuals to explain the system's purpose. Iterate and refine those explanations. Update your documentation to reflect changes in both functionality or within scope. Embed purpose in the user interface. Use built-in explanations, or tooltips, to clarify why certain outputs are generated. In this video, we introduced why articulating the purpose of AI is a critical responsibility for engineers, emphasizing its role in building trust, accountability, and an overall ethical system. You were introduced to how explainability impacts the acceptance, performance, and responsibility of AI solutions, ensuring stakeholders and end users can understand and engage with these systems effectively. We also discussed strategies for integrating explainability into AI workflows, from documenting purpose during design to embedding explanations into user interfaces. Ultimately, this enhances collaboration, compliance, and user confidence. Now that we've explored the importance of defining and explaining the purpose of AI, take a moment to reflect on how incorporating explainability into your systems could enhance trust, collaboration, and the overall impact of your projects. If you're running a logistics company, then you know that every delay costs both time and money. But with the right AI tools, you could dynamically adjust delivery routes in real time, accounting for things like traffic, weather, and scheduling to ensure faster, more efficient operations. We'll explore how AI-driven workflow optimization is revolutionizing industries, enabling faster, smarter, and more efficient processes that redefine how tasks are executed and outcomes are achieved on a global scale. By the end of this video, you'll be able to describe the key ways AI impacts workflows and operations. You'll be able to explain how AI tools integrate into existing processes to improve efficiency and outcome. You'll also be able to discuss the considerations for incorporating AI into workflow design. AI has emerged as a game changer in workflow optimization, transforming how tasks are executed and how decisions are made. By automating repetitive tasks, analyzing large data sets, and making predictions that guide decision-making, AI enhances efficiency and accuracy. Its integration into workflows enables systems to dynamically adapt to changing needs, resulting in processes that are not only faster, but also more precise and responsive. AI optimizes workflows by automating routine tasks, such as data entry and report generation, allowing human resources to focus on higher value activities. Machine learning algorithms analyze data patterns to optimize resource allocation, reduce inefficiencies, and predict future need. For instance, predictive maintenance systems monitor equipment health and schedule repairs proactively, minimizing downtime and cost. Additionally, AI-driven platforms streamline workflow integration by connecting disparate systems and enhancing communication. In customer service, for example, AI chatbots handle basic inquiries, freeing human agents to manage complex cases, improving both response times and customer satisfaction. Integrating AI into workflows requires careful planning to ensure seamless and effective implementation. Key considerations include identifying repetitive or high-volume tasks that are suitable for automation, ensuring the quality and availability of data for AI training and operations, and regularly monitoring AI performance to maintain accuracy and reliability. Thoughtful integration helps maximize AI's benefits while minimizing potential disruptions to existing processes. A logistics company optimizing delivery routes with AI showcases the tangible benefits of AI-driven workflow optimization. By analyzing traffic patterns, weather conditions, and delivery schedules, the AI system dynamically updates the routes in real time. This approach minimizes travel time. It reduces fuel consumption and it enhances operational efficiency, ultimately leading to significant cost savings. This example highlights how AI can transform workflows by improving accuracy and adaptability in a complex, data-driven environment. In this video, we introduced how AI is transforming workflows across industries by automating repetitive tasks, analyzing large data sets, and optimizing the decision-making process. You were introduced to the ways AI enhances workflows through resource allocation, predictive capability, and seamless integration of systems, enabling more efficient and adaptable operations. We also discussed the key considerations one must make when integrating AI into workflows, including identifying suitable tasks, ensuring data quality, and of course, monitoring performance. Now that we've explored how AI reshapes workflows, take a moment and reflect on how integrating AI could elevate your own processes and drive better outcomes in your projects. If you run a business, then you know that every interaction with your product or service can shape, positively or negatively, your brand's reputation. Now imagine you can help shape those interactions using custom AI tools. With them at your disposal, you could provide instant support for routine inquiries while reserving human expertise for complex, personalized interactions, creating a seamless and impactful experience for your customers. We'll explore how the parallel economy of AI-driven and human-centric solutions is reshaping industries, driving innovation, and offering consumers unprecedented choice to match their needs and values. By the end of this video, you'll be able to define the concept of a parallel economy as it applies to AI and human-centric solutions. You'll be able to describe how these dual options shape industries and consumer preference. You'll also be able to discuss the implications for innovation, ethics, and accessibility. The concept of a parallel economy highlights the growing consumer choice between AI-driven solutions and human-centric options. When I first introduced this concept back in 2023, my idea drew parallels to the emergence of organic food products alongside more conventional farming practices. AI-driven solutions emphasize efficiency and scalability, while a human-centric approach prioritizes personal touch and ethical consideration. For example, in healthcare, AI systems offer rapid, data-driven diagnoses, whereas human doctors provide nuanced, empathetic care, catering to diverse customer needs and values. This duality reflects the varying priorities of consumers and industries in an ever-evolving marketplace. The emergence of the parallel economy is driven by the rise of AI technologies, which have created significant opportunity for automation and optimization, allowing speed and data analysis to dominate in many tasks. At the same time, however, there is a growing demand for both transparency and empathy as individuals and industries increasingly prioritize accountability as well as human interaction. This divergence has shaped a marketplace where AI excels in delivering efficiency, while human-centric options continue to thrive in areas that require intuition and empathy, catering to those diverse needs and preferences. The parallel economy has significant implications for industries and for innovation, driving competition and encouraging refinement on both sides. AI providers are challenged to improve transparency and adaptability, while human-centric providers focus on ethical practices from personalized services. This coexistence allows both options to evolve and meet diverse market demands, ensuring consumers benefit from solutions that balance both efficiency with empathy. The parallel economy presents both challenges and opportunities as it continues to shape industries. One key challenge is educating consumers about the trade-offs between AI-driven and human-centric solutions, ensuring they understand the strengths and limitations of each. Transparency is also critical, as it enables informed decision-making and builds trust within these systems. On the other hand, the parallel economy offers significant opportunities, particularly through hybrid models that blend AI tools with human expertise. In this video, you learned how the parallel economy is transforming industries by presenting consumers with a choice between AI-driven solutions, which prioritize efficiency and scalability, and human-centric options, which focus on personal touch and ethical consideration. You also explored the dual priorities that define this economy, understanding how AI excels in automation and optimization, while human-centric approaches thrive in areas requiring intuition and empathy. Additionally, we highlighted real-world impacts, such as AI optimizing workflows and handling routine tasks, while human-centric solutions address complex or emotionally sensitive needs, ensuring a balanced and inclusive approach to innovation. Now that we've explored the concept of the parallel economy, take a moment to reflect on how balancing AI-driven efficiency with human-centric values could transform the way your projects and systems are designed, executed, and ultimately experienced. Imagine being part of a team where AI tools seamlessly collaborate with human expertise to solve complex problems. With augmented workflows, routine tasks are automated, freeing you to focus on creative solutions and strategic decisions, transforming how work gets done. We'll explore how augmented enterprises combine the power of AI-driven automation with human creativity, revolutionizing workflows and reshaping industries to create more dynamic and efficient workplaces worldwide. By the end of this video, you'll be able to define the concept of augmented enterprises and their role in the evolution of work. You'll be able to describe how workflows evolve from basic software tools to AI-led automation. You'll also be able to discuss the opportunities and challenges in creating an augmented enterprise. Augmented enterprise represent the next stage in the evolution of work, where AI-driven systems seamlessly integrate into workflows to enhance productivity and decision-making. Rather than replacing humans, these systems redefine roles by combining human ingenuity with machine efficiency. Moving beyond basic software tools, augmented enterprises blend traditional task-oriented applications with fully autonomous systems, overseen and guided by human experts, to create a transformative collaboration between both technology and people. The evolution of workflow in augmented enterprises follows a clear progression, beginning with basic software tools like spreadsheets and email that streamline individual tasks. This advanced into integrated systems such as ERP and CRM platforms, which automated and connected more complex processes. Today, workflows are undergoing a transformation driven by AI, enabling real-time decision-making, automation, and optimization. For example, in manufacturing, AI-powered systems autonomously monitor production lines, predict maintenance needs, and optimize resource allocation, with humans overseeing operations and stepping in only when necessary. This progression demonstrates how technology has increasingly enhanced efficiency and adaptability in workflow. The transition to augmented enterprises is reshaping the workplace by offloading repetitive, data-intensive tasks to AI, allowing employees to focus on creative, strategic, and interpersonal activity. This hybrid model enhances productivity, improves agility, and reduces operational cost. For example, in financial institutions, AI-driven algorithms efficiently handle portfolio analysis, fraud detection, and trade execution, providing faster and more accurate results. Financial advisors then leverage these insights to craft personalized strategies, fostering seamless collaboration between humans and AI while maximizing the strengths of each. Augmented enterprises present significant opportunities and significant challenge. They unlock efficiency and innovation through augmented workflows and enable hybrid models where AI empowers human expertise rather than replacing it. However, these advancements come with challenges, including the need for substantial investments in infrastructure, chaining, and change management, as well as addressing ethical concerns like data privacy and workforce displacement. By carefully planning and upskilling employees, organizations can overcome these challenges and fully realize the transformative potential of augmented enterprises, creating a balanced and productive future of work. In this video, you learned about augmented enterprises and their role in integrating AI-driven systems into workflows to enhance productivity and decision-making. You explored the evolution of workflows, transitioning from basic software tools to AI-powered automation that enables real-time decision-making and optimization. The importance of augmented enterprises was highlighted, showcasing their ability to offload repetitive tasks, refocus human effort on creative and strategic activity, and boost efficiency through hybrid collaboration between humans and AI. Additionally, you gained insight into the opportunities and challenges of creating an augmented enterprise, including unlocking innovation and addressing ethical concerns such as data privacy and workforce displacement. Now that we've explored the potential of augmented enterprises, take a moment to reflect on how combining AI-driven efficiency with human expertise could transform the way your workflows are designed and executed. How can you trust an AI system to evaluate something as complex as teamwork or teaching effectiveness? What if the metrics it uses miss the mark entirely, leading to inaccurate or, worse, fabricated outcomes? In this video, we'll uncover the hidden red flags in AI deployment, those subtle warning signs that can erode trust, skew results, and compromise fairness. We'll explore how recognizing red flags in AI deployment can lead to a more responsible and trustworthy system, ensuring that AI-driven solutions enhance fairness and integrity while transforming industries worldwide. By the end of this video, you'll be able to identify common red flags in AI projects that involve the quantitative assessment of qualitative outcomes. You'll be able to explain why these red flags matter and how they can lead to biased or misleading results. You'll also be able to discuss practical strategies to address these challenges while maintaining accountability. Red flags in AI deployment are warning signs that highlight potential issues in design, implementation, or evaluation of AI systems. A critical area where these arise is in the quantification of qualitative outcomes, such as emotion, cultural practice, or ethical decisions. Quantifying complex phenomena often oversimplifies them, removing critical context and resulting in unintended consequences. For example, an AI system tasked with assigning numeric values to teamwork might rely on proxy metrics like email response times or meeting participation, which fail to accurately capture the essence of true collaboration. This results in skewed evaluations and therefore unreliable outcomes. Red flags in AI deployment are critical because they highlight issues that can compromise the integrity and fairness of the AI system. One significant concern is oversimplification. Quantifying complex phenomena often oversimplifies them. This practice is known as reductionism. These issues can further erode trust, as stakeholders are less likely to have confidence in AI systems that produce results perceived as either arbitrary or perhaps unfair. Addressing these red flags is essential to ensure the reliability and ethical application of AI. As an AI practitioner, addressing these requires both a proactive and responsible approach. It involves critically evaluating metrics to ensure they are both appropriate and meaningful, while validating these choices with input from stakeholders to maintain both relevance and fairness. Transparency is equally crucial, necessitating through thorough documentation how metrics are selected and clear communication of their limitations is passed along to stakeholders. Additionally, incorporating human oversight is essential to balance AI capabilities with human judgment, using AI to augment rather than replace human decision-making. Engaging human reviewers to provide context and correct errors ensures a more comprehensive and therefore accountable system. A university using AI to evaluate teaching effectiveness, for example, based on student reviews, illustrates the importance of addressing red flags in AI deployment. The problem arises when the system relies on simplistic metrics, such as word counts or sentiment scores, which fail to capture the depth and nuance of qualitative feedback. To resolve this, the university could incorporate human reviewers alongside AI-generated insights, creating a more comprehensive evaluation process. This hybrid approach balances the efficiency of AI with the contextual understanding of human judgment, helping to ensure fair and meaningful outcomes. In this video, you learned about the importance of recognizing red flags in AI deployment, particularly when attempting to quantify qualitative outcomes. These red flags can undermine the integrity and fairness of AI systems by oversimplifying complexity, introducing bias through inappropriate metrics, and eroding trust when results are perceived as arbitrary or unfair. You also explored your responsibilities as an AI practitioner, including critically evaluating metrics to ensure they are meaningful, emphasizing transparency by documentation, and explaining metric choices. Further, incorporating human oversight to provide context and correct potential error. A real-world example demonstrated how combining AI-generated insight with human reviewers can create a more comprehensive and powerful evaluation process, highlighting the balance needed between efficiency and fairness. Now that we've explored the challenges and responsibilities of deploying AI systems, take a moment to reflect on how addressing red flags and ensuring fairness, transparency, and accountability could transform the impact and reliability of your own projects. What if the AI system diagnosing your next medical scan got it wrong? Could you trust it to explain why? In the high-stakes world of AI, especially in fields like healthcare, the consequences of ethical lapses can be life-altering. From ensuring accuracy across diverse populations to safeguarding sensitive data, deploying AI responsibly requires more than technical expertise. It demands accountability. Today, we'll explore strategies to identify and mitigate ethical risks in AI deployment, helping you build systems that are not just powerful, but also trustworthy and responsible. By the end of this video, you'll be able to describe the ethical challenges associated with a specific AI use case. You will be able to describe strategies to identify and mitigate these ethical risks effectively, ensuring your AI systems are both innovative and responsible. Additionally, you'll be able to discuss actionable solutions that strike a balance between driving technological advancement and maintaining accountability in real-world applications. Our use case today is AI in healthcare diagnostics. Imagine an AI system designed to analyze medical imaging data, such as X-rays or MRIs, to assist doctors in diagnosing diseases. This use case holds enormous potential for improving diagnostic accuracy and reducing workload for overworked healthcare professionals. However, it also introduces several ethical considerations. First is reliability and accuracy. The AI system must perform consistently across diverse patient populations and medical conditions. Any inaccuracies could lead to misdiagnoses, potentially harming patients. Next is transparency. Physicians and patients need to understand the bias for the AI system's recommendation. A lack of explainability can undermine trust in the technology. Next is accountability. Determining who is responsible for decisions made with AI assistance, whether that's the healthcare provider, the AI developer, or some mix of each, is critical for ensuring proper oversight. Then there's data privacy. Medical imaging data often contains sensitive patient information. Safeguarding this data is essential to maintaining patient confidentiality and complying with legal requirements. There are a few mitigation strategies to help us along. To address these challenges, healthcare providers and AI developers can take steps like these. First, they can validate performance across diverse populations. This requires conduction of extensive testing to ensure the AI system is reliable for patients of different ages, ethnicities, and medical histories. This will help minimize the risk of inaccuracies. Next, they can enhance transparency. By incorporating explainable artificial intelligence techniques that allow doctors to understand how the system arrived at a specific diagnosis or recommendation. This will help build confidence in the technology, both in patient and practitioner. Next, they can define accountability frameworks. By establishing clear guidelines that delineate the responsibilities of healthcare providers and AI developers, for instance, by ensuring that physicians retain the ultimate authority over clinical decisions. They can also implement powerful data security measures. They can use encryption and anonymization techniques to protect sensitive patient information. Regular audits can ensure compliance with privacy regulations like HIPAA. In this real-world example, a hospital network adopted an AI diagnostic tool to detect early signs of lung cancer from CT scans. While the system initially flagged some false positives, a collaborative review process between radiologists and AI engineers refined the model. By integrating explainable AI and ensuring doctors made the final decisions, the hospital improved diagnostic accuracy and maintained patient trust. In this video, you learned about ethical challenges, strategies for identifying and mitigating ethical risk, and actionable solutions. Now that you've explored strategies for identifying and mitigating these ethical risks in AI deployment, it's time to act. Are your AI solutions reliable, transparent, and accountable in real-world applications like the one we discussed today? How can you ensure they address diverse needs while safeguarding sensitive data? Try applying these insights to your projects by testing your systems across diverse populations, enhancing transparency, and defining accountability frameworks. Building responsible AI isn't just about innovation. It's about both trust and impact as well. Take steps today to create AI solutions that are as ethical as they are powerful. Imagine running a complex AI model on a single machine, only to find it struggling under the weight of massive data sets. With distributed computing, you can spread the workload across multiple machines, enabling seamless performance and faster results to tackle challenges at scale. We'll explore how distributed computing is revolutionizing the way we process data and scale AI, enabling groundbreaking advancements across industries and tackling challenges once thought insurmountable. By the end of this video, you'll be able to describe the fundamental concepts of distributed computing. You'll be able to explain why distributed computing is essential for handling large-scale AI/ML tasks, and you'll be able to describe the key components and examples of distributed computing systems. So what is distributed computing? Distributed computing refers to the practice of spreading computational tasks across multiple machines to achieve greater performance, efficiency, and scalability. Instead of relying on a single computer to handle all the workload, distributed systems leverage the power of interconnected nodes, allowing tasks to be executed in parallel. Think of it like a team effort. Instead of one person building an entire home, a crew works together, each focusing on specific tasks to complete the project faster and more effectively. Why is distributed computing essential? Well, in AI/ML, data sets are growing larger and models are becoming increasingly more complex. Single machine solutions often fall short due to limited processing power, sometimes memory limitations or storage. Distributed computing addresses these limitations. It does so by enabling scalability. Systems can grow by adding more machines, allowing you to handle increasing workloads seamlessly. They improve performance. Parallel processing speeds up computations, making real-time analysis and training of large AI models feasible. They also enhance reliability. Distributed computing can continue functioning even if a single node fails, ensuring minimal downtime. Now, let's talk about some of the key components of distributed computing. First up, nodes. The individual machines or servers that participate in the system. Each node performs a portion of the total computational task. Network. This is the communication infrastructure that connects the nodes, enabling them to share data and results. Middleware. This is the software layer that manages task allocation, communication, and synchronization amongst nodes. Load balancing. This is a mechanism to evenly distribute tasks across nodes, ensuring optimal resource utilization. A classic example of distributed computing is Apache Hadoop, an open source framework for processing large data sets. By breaking data into chunks and distributing it across a cluster of machines, Hadoop performs parallel processing efficiently to deliver results directly to you. Companies like Facebook and Twitter rely on similar systems to analyze vast amounts of user-generated data in real time. Or think about organizations handling massive data sets like healthcare systems analyzing patient records to detect critical patterns. With distributed computing, tasks can be spread across multiple machines, enabling real-time processing, more accurate results, and seamless scalability. We'll explore now how distributed computing makes such a transformative effort in applications possible and how it can unlock new possibilities in your AI/ML projects. In this video, you learned how distributed computing transforms data processing, scalability, by enabling tasks to be spread across multiple machines for greater efficiency. You were introduced to the key components of distributed systems, including nodes, networks, and middleware, which work together to optimize performance. Additionally, real-world examples showcased how distributed computing effectively manages massive data sets, providing powerful solutions for complex computational challenges. Now that we've explored the potential of distributed computing, take a moment and reflect on how these systems could reshape the way you approach large-scale AI and data challenges. As we continue through the course, you'll gain hands-on experience to bring these concepts to life and revolutionize your projects. Imagine for a moment managing a massive data set with both tight deadlines and high expectations for performance. With the right strategies, like data sharding and parallel processing, you can distribute workloads efficiently, ensuring faster results and smoother operations. We'll explore how these techniques are driving innovation, enabling organizations to tackle large-scale challenges and revolutionizing data-driven industries worldwide. By the end of this video, you'll be able to define what data sharding and parallel processing are. You'll be able to explain why they are critical for handling large-scale data and computations. You'll also be able to discuss real-world examples of these techniques in action. So what is data sharding? Data sharding involves breaking a large data set into smaller, manageable pieces called shards, which can be stored and processed independently. Each shard contains a subset of the data, distributed across multiple nodes in a system. This reduces the load on individual machines, enhancing efficiency. Here's an example. A global e-commerce platform may shard user data by, let's say, geographic regions. North American customer data, for example, is stored in one shard, while European customer data, well, that resides in another. This minimizes latency and balances system load during peak regions. Now let's discuss parallel processing. Parallel processing divides tasks and executes them simultaneously across multiple processors or machines. Tasks are split into smaller parts that run concurrently, improving both speed and efficiency. Here's an example. Training a machine learning model by splitting the data set amongst multiple GPUs. Each GPU processes just a portion of the data, and the results are aggregated to optimize the model faster than a single processor could ever accomplish. So why are these techniques important? Mostly, it's about efficiency. Sharding and parallel processing enable systems to manage massive data sets and computationally intensive tasks within reasonable timeframes. Further, they also allow for scalability. These methods allow systems to grow seamlessly by adding more nodes or processors, avoiding performance bottlenecks. They also improve reliability. Distributed systems using sharding and parallel processing are far more resilient. If one node fails, others take over, ensuring uninterrupted operations. Here's a great real-world example. A social media platform with billions of users might perhaps shard user information over geographic regions. They would use parallel processing to analyze trends and recommend content in real time. The result? An effective workload distribution and seamless user experience on a global scale. In this video, you learned how data sharding and parallel processing play a critical role in optimizing system performance. These techniques enable the distribution of workloads across multiple nodes, improving efficiency, scalability, and reliability. We also examined real-world examples, such as how social media platforms manage vast amounts of data to deliver seamless user experiences efficiently. Now that we've delved into the power of data sharding and parallel processing, take a moment now to consider how these techniques could revolutionize the way you approach large-scale data challenges. As we move forward, you'll gain practical insight and tools to implement these strategies, turning complex projects into scalable, efficient solutions. Imagine managing a global e-commerce platform with millions of customers. Every click, every transaction generates massive amounts of data that need to be processed both quickly and efficiently. With the right technique, like data sharding, you can distribute this data intelligently, ensuring seamless performance and a smooth customer experience. We'll dive into how data sharding empowers modern systems to scale effortlessly, transforming industries and redefining how we manage big data. By the end of this video, you'll be able to define the concept of data sharding and its applications. You'll be able to describe how data sharding improves system efficiency and scalability. You'll also discuss real-world scenarios where data sharding is indispensable. So what is data sharding? By definition, data sharding involves splitting a large data set into smaller, manageable parts called shards. Each shard is stored across different nodes within a distributed system, reducing the workload on each individual machine. For example, a global online retailer can shard customer records based on regions: North America, Europe, Asia. This setup ensures faster access and reduced latency for regional queries. Some of the key benefits of data sharding include improved performance. By reducing the load on individual machines, this allows for faster query processing and, of course, lower latency. For instance, a gaming platform can shard player data by game type, enabling quicker access during peak activity. Additionally, data sharding allows for better scalability. It facilitates horizontal expansion by adding more nodes to store additional shards, ideal for businesses experiencing rapid growth. It also assists with fault tolerance. Sharded systems are inherently more resilient. If one node fails, others continue operating, ensuring minimal disruption. So how does data sharding work? A lot of it relies on the shard key. This is a field in the data set which determines how data is going to be divided. For example, customer databases might use the country or postal code as the shard key. Next up is data partitioning. Data is distributed across nodes based on that shard key. Queries are routed to the relevant shards, optimizing response times and processing efficiency. Let's look at a real-world application. An online retailer in the e-commerce sector, like Amazon, will manage inventory and customer data across regions for a seamless shopping experience. What about banking? Financial institutions shard transaction data by account numbers or geographic regions, or both, to securely handle millions of transactions. Then, of course, there's social media. Platforms like Instagram use sharding to support billions of users, ensuring rapid content delivery and minimal downtime during high-traffic events. There are a few challenges in data sharding. Let's go over them now. First up is complex design and maintenance. Careful planning is required for balanced data distribution and optimal performance. Then we have to think about rebalancing our shards. As data sets grow, redistributing shards across nodes can be both complex and very time-intensive. Then there are cross-shard queries. Queries involving multiple shards can introduce latency and complicate system design. In this video, you learned about the concept of data sharding, a technique that involves dividing large data sets into manageable parts to improve system performance, scalability, and reliability. We explored how sharding optimizes data management by distributing workloads across multiple nodes, enabling systems to handle massive amounts of data with efficiency. Real-world applications highlighted its use in industries like e-commerce, banking, social media, and gaming, where it ensures seamless operations and enhanced user experiences, even during those high-demand periods. Now that we've uncovered the potential of data sharding to enhance scalability and efficiency, take a moment now and reflect on how this technique could revolutionize your approach to data management. As we move forward, you'll gain practical insight and hands-on experience to apply these concepts, transforming your projects into robust and scalable systems. Imagine running a business where split-second decisions could mean the difference between success and failure. With the power of parallel processing, you can analyze vast amounts of data in real time, accelerating insights and driving smarter strategies. We'll explore how this revolutionary approach is transforming industries, enabling groundbreaking solutions, and redefining the possibilities of modern computing. By the end of this video, you'll be able to define the concept of parallel processing and explain how it works. You'll be able to describe its importance in modern computing, and you'll be able to discuss real-world examples of parallel processing in action. So what is parallel processing? Let's start with the definition. Parallel processing is the simultaneous execution of multiple tasks or operations to solve complex computational problems more efficiently. Instead of running one process after another, it splits the workload across multiple processors, cores, or machines, enabling tasks to be completed faster. This approach is crucial. Applications requiring intensive computation such as machine learning, simulation, and large-scale data analysis. For example, training a deep learning model involves dividing the data set into smaller batches, processed concurrently by multiple GPUs. Each GPU handles a subset of the data, performs computations, and shares results with a central system. This distributed workload drastically reduces training time compared to sequential processing. So why is parallel processing important? Well, it enhances speed and efficiency as data volumes grow and computational demands increase. It ensures systems remain responsive to handle these challenges. For example, in finance, parallel processing analyzes market data in real time, enabling high-frequency trading or fraud detection. In meteorology, it simulates atmospheric conditions to deliver faster and more predictable forecasts. So how does it work? Parallel processing operates at a few different levels. First, the micro level. Multiple cores within a single CPU execute instructions simultaneously. Then there's the macro level. In this, clusters of machines collaborate on a distributed task. Frameworks like Apache Spark and distributed databases showcase parallelism's ability to process massive data sets across distributed systems with efficiency. There are, however, some challenges in parallel processing. Let's touch on those now. While parallel processing offers significant advantages, there are some challenges like synchronization, ensuring processes work together without errors or inconsistencies, or task dependencies. Some tasks require sequential execution, and this, of course, limits the performance gain. In this video, you learned about the concept of parallel processing and how it enables simultaneous execution of tasks to improve both efficiency and speed. We explored why parallel processing is crucial for tackling large-scale computational challenges, particularly in industries such as finance or weather forecasting, as well as machine learning. Additionally, we examined real-world applications and frameworks that showcase the transformative potential of parallel processing in modern computing. This highlighted its role in driving innovation and addressing complex, data-driven problems. Now that we've uncovered the potential of parallel processing, take a moment and reflect on how this approach could revolutionize the way you tackle complex tasks in your projects. As we move forward, you'll gain hands-on experience with tools and techniques that will empower you to implement these powerful solutions and bring your ideas to life. Imagine a world where organizations can unlock valuable insight from vast amounts of data without ever compromising individual privacy. With the power of differential privacy, you can analyze sensitive data sets securely, ensuring that personal information remains protected. We'll explore how this groundbreaking technique is revolutionizing industries from healthcare to tech and shaping the future of ethical data analysis. By the end of this video, you'll be able to define differential privacy and explain its significance in protecting sensitive data. You'll be able to describe how differential privacy balances data utility and individual privacy. You'll also be able to identify real-world applications of differential privacy across industries. So what is differential privacy? At its core, differential privacy is a technique designed to protect individual data within the context of a data set while still enabling meaningful analysis. It ensures that adding or removing a single data point does not significantly impact the results of any query or analysis. This keeps personal information secure even if the data set itself is compromised or accidentally shared. So how does it work? The method involves adding a controlled amount of noise, that is, random variations in data, to either the data itself or to the results of queries of that data. For example, when analyzing the average income in a city, differential privacy ensures that while the average remains accurate, individual incomes are now rendered unidentifiable. This is especially crucial in industries where privacy is non-negotiable, such as healthcare, protecting patient data during research or analytics, or the technology sector, ensuring user data remains anonymous while still analyzing behavior. Here's a great real-world example. Apple uses differential privacy to understand user behavior without tracking individual user behavior. Governmental statistical agencies leverage it for census data. This will protect citizens' personal information. There are, however, a few challenges within differential privacy. Implementing this technique requires careful calibration of noise levels. Too little noise, well, that might defeat the purpose and risk privacy. Too much noise, that can compromise the usefulness of the data itself. Managing these trade-offs demands expertise and meticulous planning. In this video, you learned about the core concept of differential privacy and its crucial role in safeguarding individual data. By introducing controlled noise to datasets, differential privacy ensures that individual information remains protected while preserving the overall utility of the data. Real-world applications, such as its use in healthcare analytics to protect patient confidentiality and in census data to ensure citizen privacy, highlighted the practical benefits and versatility of this technique. Now that we've uncovered the potential of differential privacy, take a moment and reflect on how this approach could redefine the way you handle sensitive data in your projects. As we move forward, you'll gain practical insight and tools to apply this principle, empowering you to innovate responsibly and build trust in your data practices. Imagine a system that can analyze massive legal documents in minutes, offering precise insight that lawyers would take hours to uncover. With neurosymbolic AI, you combine the power of neural networks for data analysis with symbolic reasoning for logical decision-making, opening doors to groundbreaking solutions in law, healthcare, and far beyond. We'll explore how this innovative approach is revolutionizing industries and solving complex challenges in ways never thought possible. By the end of this video, you'll be able to explain the concept of neurosymbolic AI and how it bridges neural and symbolic methods. You'll be able to explain why neurosymbolic AI is a promising approach to solving complex problems. You'll also be able to discuss real-world examples where neurosymbolic AI is making an impact right now. So what is neurosymbolic AI? At its core, neurosymbolic AI integrates two key areas of artificial intelligence: neural networks and symbolic reasoning. Neural networks are adept at learning from data and identifying patterns, while symbolic reasoning excels at logic-based reasoning and structured rule processing. Together, they create systems that can analyze data and reason abstractly. For instance, a neurosymbolic AI system analyzing legal documents, like we mentioned before, could use a neural network to process and extract information from text, and then apply symbolic reasoning to interpret and apply legal principles, offering actionable insight that neither method could achieve solely on its own. So why is it important? Because this hybrid approach addresses limitations in both areas. Neural networks often struggle with logical consistency, and transparency, while symbolic AI, well, that lacks the adaptability and scalability required for many modern tasks. By bridging these gaps, neurosymbolic AI enables breakthroughs in things like explainable AI, that is, providing insight into the decision-making process. Autonomous systems, it enhances navigation and adaptability. Complex decision-making, it improves frameworks for sectors like law and finance and far beyond. There are some real-world applications we'd like to introduce you to as well. For example, healthcare. Neurosymbolic AI analyzes patient data using neural networks and applies medical guidelines through symbolic reasoning to suggest accurate diagnoses and treatment courses. Education. Systems that combine learning analytics with curriculum design, well, this provides personalized learning pathways for students. There are a few challenges in neurosymbolic AI. For example, the integration requires advanced techniques for seamless interaction. And you have to balance trade-offs between flexibility, scalability, and logical rigor. In this video, you learned how neurosymbolic AI combines the pattern recognition capabilities of neural networks with the structured reasoning of symbolic AI. We explored why this approach is transformative for solving complex problems, such as integrating perception with logical decision-making. You also saw real-world examples, including applications in healthcare and legal analysis, demonstrating the potential of neurosymbolic AI to enhance accuracy and maintain interpretability during critical tasks. Now that we've uncovered the potential of neurosymbolic AI, take a moment to consider how blending learning and reasoning could redefine the way you approach problem solving in your projects. As we move forward, you'll gain hands-on experience that will help you bring these transformative ideas to life. Imagine designing a system that combines the predictive power of neural networks with the precision of physical laws to tackle problems in climate modeling, healthcare, and engineering. With physics-informed neural networks, or PINNs or PINs, you can simulate complex systems like blood flow, material stress, or atmospheric behavior with unparalleled accuracy and efficiency. In this lesson, we'll explore how PINs are revolutionizing industries by blending AI's flexibility with the reliability of physics, unlocking groundbreaking possibilities for innovation and problem solving. By the end of this video, you'll be able to understand the concept of physics-informed neural networks and their unique approach to artificial intelligence. You'll be able to explain why PINs are transformative for solving complex scientific and engineering problems. You'll also understand how PINs bridge AI and physics. PINs represent a cutting-edge class of neural networks that directly integrate physical laws into the learning process. Traditional neural networks rely exclusively on data, but PINs incorporate equations governing natural phenomena such as fluid dynamics or electromagnetism or structural mechanics. This approach ensures that the network outputs align with established physical principles, improving both efficiency and generalizability. PINs embed differential equations, such as Navier-Stokes or Maxwell's equations, into their loss function. By penalizing solutions that violate these laws, PINs deliver results that respect the constraints of the physical world. This methodology makes them especially powerful for solving partial differential equations, simulating physical systems, optimizing engineering designs. Take the modeling of airflow over an airplane wing. Traditional computational fluid dynamics, these methods demand extensive time and resources. Pins streamline the process by approximating flow behavior using fewer resources while maintaining high accuracy through their inherent physics-based training. Pins are already transforming various fields, including climate modeling. They simulate atmospheric and oceanic behaviors. In the field of biomedicine, they model complex processes like blood flow or tissue deformation. In structural engineering, they predict material stresses or strains under load. Renewable energy, they optimize designs for wind turbines or solar panels. Despite their promise, implementing pins comes with a few hurdles. Let's touch on them now. Embedding complex physical laws requires domain expertise and meticulous design, both. Training pins can be computationally intensive, especially for high-dimensional or highly intricate problems. In this video, you learned how physics-informed neural networks, PINNs or pins, integrate the principles of AI with the fundamental laws of physics, offering a transformative approach to solving complex scientific and engineering problems. You explored why pins are uniquely powerful, leveraging physical laws to enhance efficiency and accuracy in applications such as climate modeling, biomedicine, or structural engineering. By bridging the gap between AI and physics, pins open up new possibilities for modeling, simulation, and design across diverse fields. Now that we've uncovered the potential of physics-informed neural networks, pins, to revolutionize problem solving in science and engineering, take a moment and reflect on how these hybrid systems could redefine your approach to tackling a complex challenge. As we move forward, you'll dive deeper into practical applications and gain hands-on experience to turn these groundbreaking ideas into your own actionable solutions. Imagine developing a recommendation system that instantly understands a shopper's preferences, boosting both satisfaction and sales. With the skills of an AI/ML engineer, you could harness data to design intelligent solutions like this one, transforming industries in real time. In this lesson, we'll dive into the diverse responsibilities of AI/ML engineers and explore how they shape the future of technology. By the end of this video, you'll understand the core responsibilities of AI/ML engineers. You'll learn how these roles contribute to the development and deployment of intelligent systems. You'll also explore how AI/ML engineers collaborate across multidisciplinary teams. AI/ML engineers design, build, and deploy machine learning models that address real-world challenges. Their work combines technical expertise and creative problem-solving to develop systems capable of learning from data and making intelligent decisions. First, they engage in model development. They create algorithms and models for tasks like image recognition, natural language processing, or predictive analytics. Next, they'll need to select a model architecture, pre-process data, and optimize hyperparameters for peak performance. Then they need to engage in data management. This involves collection, cleaning, and pre-processing of large data sets for both training purposes and validation. They'll also perform data augmentation and feature engineering to boost their model's overall ultimate accuracy. The next step is system integration. They have to integrate models into production environments using APIs or cloud platforms. This ensures scalability, reliability, and seamless compatibility with existing systems. Next up is performance monitoring. They'll track key metrics and identify issues such as data drift post-deployment, or they'll engage in retraining models to maintain their accuracy and efficiency over time. Finally, there's collaboration. They'll work alongside and with data scientists, software engineers, and business stakeholders. Often they'll be called upon to translate technical concepts or jargon into actionable insight to align with organizational goals and milestones. Imagine a retail company, for example, aiming to enhance customer recommendations. An AI ML engineer would collect and pre-process user behavior data. They would then develop a recommendation algorithm tailored to those customer preferences, and then deploy the model into the company's e-commerce platform. Once deployed, they would continuously monitor and retrain when necessary the system to ensure relevance as customer preferences evolve. In this video, you learned about the core responsibilities of AI ML engineers, including designing and optimizing machine learning models, managing and pre-processing data, integrating models into production systems, and monitoring their performance to ensure reliability. You also explored how engineers collaborate across multidisciplinary teams, working with data scientists, software developers, and business stakeholders to align technical solutions with organizational goals. Finally, real-world applications were highlighted, demonstrating the transformative impact of AI ML engineering in industries such as retail, healthcare, and beyond. Now that we've uncovered the dynamic role of AI ML engineers and their responsibilities, take a moment to reflect on how these skills could be applied to your projects. As we move forward, you'll gain hands-on experience that will empower you to turn your ideas into impactful solutions that fit your business stakeholders. Imagine a logistics network that processes thousands of packages daily, where even a minor delay could disrupt deliveries across the globe. With the right AI tools, you could analyze operational data in real time, identifying bottlenecks and optimizing routes for seamless efficiency. In this course, we'll explore how cutting-edge AI and ML technologies are transforming industries like logistics, enabling smarter, faster, and more impactful solutions worldwide. By the end of this video, you'll understand the principles of optimizing machine learning operations, or ML ops. You'll explore the tools and practices that streamline the ML lifecycle. You'll also learn how optimization enhances scalability and reliability. Optimizing machine learning operations involves refining the processes that take models from development to deployment and ultimately to maintenance. The goal is to create systems that are efficient, that streamline workflows to reduce manual effort, systems that are scalable, that adapt to increased workloads seamlessly, systems that are reliable, systems that ensure consistent and accurate performance. The components of ML ops include automation. Automating tasks like data pre-processing, model retraining, and deployment allows teams to focus on innovation. The tools to accomplish this, like Apache Airflow, Kubeflow for workflow orchestration. Next is version control. This includes tracking changes in data and in models to ensure reproducibility and traceability. The tools at work here include Git for code, DVC or data version control for datasets and models. Next, performance monitoring. Continuously monitor models to maintain performance and address data drift or concept drift. The tools at work here include MLflow, Prometheus for tracking metrics and, if necessary, triggering alerts. Next is resource management. Efficiently manage computational resources to balance cost and performance. The features here, like auto-scaling on AWS or Google Cloud, enable dynamic adjustments. Next, security and compliance. You must, of course, protect sensitive data to ensure adherence to regulations like GDPR or HIPAA. Techniques here include role-based access control, or RBAC, and of course, encryption. So let's take a look at a real-world example. A financial technology company deploying a fraud detection model uses optimized ML ops to automate retraining with new transaction data. They use it to track dataset changes with data version control, DVC, for transparency's sake. They monitor model accuracy with Prometheus. They also scale resources dynamically during high transaction periods. In this video, you learned about the fundamental principles of optimizing machine learning operations, or ML ops, focusing on enhancing efficiency, scalability, and reliability. Key tools and practices such as automation, version control, and performance monitoring were explored to streamline the ML lifecycle. Additionally, the video highlighted how these optimizations contribute to robust workflows, ensuring compliance and adaptability in real-world machine learning applications. Now that we've uncovered the essentials of optimizing machine learning operations, take a moment to consider how these strategies could elevate your workflows and enhance your system's overall performance. As we move forward, you'll gain hands-on experience with tools and practices, like many that we discussed in this video, that will turn these concepts into actionable results. In the dynamic world of artificial intelligence, the true impact of machine learning goes far beyond the lab. Understanding its real-world implication is critical. Today, we'll uncover how pragmatic considerations shape the journey from technical success to meaningful impact in the real world. By the end of this video, you'll be able to explain the concept of pragmatic implications within the context of machine learning workflows, gaining insight into how these systems influence real-world scenarios. You'll identify key factors shaped by ML outputs, such as user behavior, operational impact, or broader societal effect. Additionally, you'll learn to connect technical results to their practical and behavioral outcomes, ensuring that your machine learning solutions not only perform well, but also align with ethical considerations and societal needs. Pragmatic implications extend the impact of machine learning from technical accuracy to broader societal or behavioral effects. While a recommendation system may excel in tests, for example, its real-world impact, like influencing purchasing decisions, is where its value truly lies. When deployed, machine learning models interact with users' systems in real-world environments, introducing complexities absent in controlled test setups. External factors like user behavior, contextual shifts, and feedback loops can amplify or suppress outcomes in very unexpected ways. So why is this important? Because ignoring pragmatic implications can result in serious unintended consequences, such as harm to user trust or damage to business operations. Machine learning professionals must go beyond performance metrics and prioritize real-world utility, fairness, and ethical considerations. Here are some of those real-world manifestations. Behavioral shifts. Recommendation engines influence user choices and habits. For example, prioritizing high-click products might reduce diversity in user consumption and inadvertently reinforce certain purchasing behavior. Operational impacts. Workflow optimizations driven by ML can create bottlenecks elsewhere in an organization, requiring continuous monitoring and adjustment. Here are some of those examples in practice. In autonomous vehicles, for example, while technically proficient, these systems raise serious questions about pedestrian trust, urban planning, or ethical accountability during an accident. Pragmatic implications address how this technology will ultimately integrate into society. E-commerce recommendation systems is another example. Focusing again solely on high-margin products can alienate cost-conscious consumers or perpetuate stereotypes. Balancing profitability with user satisfaction demands a dynamic feedback loop and, of course, an ethical design principle. So why does this matter? Because again, overlooking pragmatic implications can lead to these unanticipated challenges, things like user dissatisfaction, reduced system effectiveness, or, in the worst sense, even broader societal harm. Strategies such as a regular audit, a scenario analysis, and a stakeholder engagement can help mitigate these risks, ensuring machine learning systems align with real-world needs. In this video, you explored the concept of pragmatic implications in machine learning workflows, emphasizing their significance in real-world applications. You learned about key factors influenced by ML outputs, like user behavior or operational impacts, as well as societal effects. These highlight the broader reach of machine learning beyond mere technical accuracy. Additionally, you discovered how to bridge the gap between technical results and their societal and behavioral outcomes, ensuring that ML solutions are both responsible and impactful in a practical context. Now that you understand the pragmatic implications of machine learning, take action by evaluating your current or future projects. Here are some questions you can ask yourself. How will this solution influence user behavior or operations in the real world? What unintended consequences might arise from this application? And most importantly, what steps can ensure ethical, practical, and impactful outcomes? Apply these insights to improve your models, ensuring they drive positive, real-world change. In the dynamic world of machine learning, scaling your model to meet real-world demands can be both an opportunity as well as a challenge. But there's a way to strike that perfect balance: scalability strategies. Today, we'll explore how to scale ML solutions effectively, optimizing both performance and cost to ensure your systems excel in any environment. By the end of this video, you'll be able to explain the relationship between scalability and performance in ML systems. You'll be able to identify key cost factors involved in scaling machine learning models. You'll also be able to apply strategies effectively to balance cost and performance in ML solutions. Let's begin with scalability and performance. Scaling an ML model means expanding its capacity to manage larger data sets, more users, or increasingly complex tasks. However, scalability isn't just about adding resources. It requires maintaining efficiency and effectiveness at this now increased scale. For example, an ML model driving e-commerce recommendations must handle a growing user base while delivering real-time, personalized suggestions. Achieving this demands efficient infrastructure, distributed computing, caching of frequently accessed data, and continuous performance testing to resolve bottlenecks. Then we have to think about cost implications. Scaling ML models introduces financial costs tied to computation, storage, and data transfer. These expenses must be evaluated when choosing model complexity and infrastructure. For instance, a manufacturing firm using a predictive maintenance model might turn to edge computing to reduce latency. While edge solutions provide speed, they come with a far higher initial cost. Balancing these expenses against potential long-term savings, such as minimizing equipment downtime, is key to effective scalability. Here are some strategies for balancing cost and performance. First up, auto-scaling. This dynamically adjusts computational resources based on workload to prevent over-provisioning. Next, simplifying model architecture. Utilizing lightweight frameworks enhances efficiency and therefore reduces cost. Then we have hybrid solutions. Combining cloud and on-premise infrastructure meets performance needs while being cost-effective. Then there are regular audits. Reviewing infrastructure and processes highlights opportunities for further cost savings. Here's a great real-world example. An online streaming service initially used a deep learning recommendation engine. As the platform grew, computational costs became unsustainable. By implementing a hybrid approach, using collaborative filtering for frequent users and a simpler model for less active accounts, the company cut costs while maintaining quality recommendations for all users. This strategy showcased the importance of thoughtful scalability planning. In this video, you learned about the key principles of scaling machine learning models to ensure efficiency and maintain performance as demands inevitably grow. You explored how cost implications play a significant role in scalability decisions, highlighting the need to carefully evaluate expenses related to computation, storage, and data transfer. Additionally, you discovered effective strategies to balance cost with performance, such as auto-scaling, simplifying model architecture, or adopting hybrid solutions. A real-world example also illustrated the importance of thoughtful scalability planning, showcasing how businesses can optimize resources while still maintaining high-quality outcomes. Now that you've learned about scaling machine learning models, it's time to take action. Are your systems ready to handle growth without losing performance? How can you balance cost and efficiency with strategies like auto-scaling or hybrid? Identify bottlenecks and plan for growth to ensure your models scale effectively and smartly. Learning to apply these techniques will ensure powerful and dynamic solutions suitable for real-world scenarios.
So an AI ML engineer in particular can really get caught in the crossfire between the misalignment that occurs between the front end of the house, the business side of the house, and the development side of the house. When there are misalignments in priorities specifically, and that might be a priority on the roadmap, it might be a priority in a specific sprint, it might be a priority in a task within a specific sprint, within a roadmap. And I think that the AI ML role in particular does get caught in the crossfire when there's misalignment on the priorities. And it's specifically because the work is so centered around agentic design and around the semantic processing. So what's fascinating here is that we're talking about a very language-based process in developing AI and ML. You have libraries, you have prompt engineering, you have fine-tuning that needs to happen in both areas as you do the work. And it's actually a very human experience to apply the technical requirements and the business requirements to the AI ML development process. To me, this is really fascinating because I have spent a career with one foot in both sides of the house, each side of the house. So this is really a role that becomes a bridging role, and a deep understanding of language and a deep understanding of the impact of language, terms, definitions, clarity. A deep understanding of all of those things is really essential here. What's also interesting too is that the work is not as prescriptive as your typical development coding. Now, that said, as you know, going through these courses, there's a lot of coding involved, right? You're using Python, you're using, multiple things. And so there's elements of everything. So this position becomes this bridging position where misalignment really comes to a head when doing the AIML work. And I think that it's uniquely on the shoulders of the AIML engineer sometimes to point out when there's a misalignment, when there's a discrepancy. And because that position is closest to it and can identify when even the smallest misalignment can actually result in a really critical gap down the road. So understanding that impact, number one, is this a misalignment? What might be the impact is really important to communicating externally to non-technical folks, especially why this minuscule thing might actually be a pretty big deal down the road. And so being able to really talk about why is important. Being able to draw it out visually and draw out some of those worst case scenarios can be really valuable for helping multiple people understand more deeply what's happening here, and being able to share that information out with other stakeholders. But I also want to take a step back and talk about how important it is for a mirroring kind of process to happen within the development team. So as an AIML engineer, you may turn to another developer and share one of these things. One of these things that you've identified might be a small and significant thing now, but it might turn into something bigger later. Turn to your fellow developers, share it with them, and then here's the really valuable part. Have them mirror it back to you. And when you hear how they've translated what you've shared with them, you might have additional aha moments that will help you, take that input and explain it in a slightly different way. So that process of mirroring back and forth these ideas within the development team is actually really key. On every project that I've worked on, across the development team, there's actually quite a bit of collaboration that happens, even though at first glance it seems like a solitary role. There's always a lot of healthy collaboration that yields an even better end product.
As we approach the end of this course, let's take a moment to reflect on the journey so far. All throughout this course, you've gained valuable insight into advanced AI/ML techniques, explored practical strategies for scalability and optimization, and dived into real-world applications that highlight the transformative power of machine learning. Wrapping up doesn't mean the learning stops. It's about consolidating these concepts and preparing to apply them in meaningful ways. By the end of this video, you'll be able to summarize key principles and advanced techniques in AI/ML engineering while applying practical strategies for scalability, cost optimization, and effective deployment. You'll be able to describe cutting-edge approaches including transfer learning, Ensemble methods, and ML ops, and recognize the importance of addressing ethical considerations in AI/ML projects. Additionally, you'll be able to evaluate how to apply your skills to drive innovation and tackle complex problems in real-world scenarios. Completing this course is not just a milestone, it's in fact a launchpad for your journey as an AI/ML professional. Through these modules, you've gained a thorough understanding of foundational and advanced AI/ML principles. You've explored practical strategies for scalability, cost optimization, and deployment, and mastered cutting-edge techniques such as transfer learning, Ensemble methods, and ML ops practices. But beyond technical skills, you've considered the real-world implications and ethical challenges of deploying machine learning systems. These competencies empower you to address complex challenges, create impactful solutions, and drive meaningful innovation in AI and machine learning. In this video, you learned about the comprehensive journey through AI/ML engineering principles and advanced techniques, including practical strategies for scalability, cost optimization, and deployment in real-world scenarios. You explored cutting-edge methods such as transfer learning, Ensemble methods, and ML ops practices, while also understanding the importance of addressing ethical challenges and considering real-world implications in deploying machine learning systems. With these insights, you are now positioned to tackle complex challenges and drive innovation in the dynamic field of AI and machine learning. I would just like to say thank you for coming along with us on this journey. Congratulations again. We can't wait to see what you build.